The music is very soft right now, but I forgot to blah 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 blah. I forgot to load up some of my junk. Get that up, that up. Okay. I didn't really have that much to load up anyway. But, you know. You know. I think I forgot was to grab my Unity ID stuff. That's the wrong one. Click the wrong account. The wrong account. Did I just mess this up already? There we go. Clicks the wrong Google account. My fault. Well, I guess I'll wait for that to take forever really quick. Oh. Excuse me. We are at Unit 4. I think I already did the introduction. Yeah, I already did the introduction. We got through that. So now we need the watch where you're going. Excuse me. I just got done eating my dinner at like 8. Oh, made a little beef stroganoff kind of thing. Very good. Threw in some broccoli too. Made sure to have a veggie and all that. Good since I've been exercising so much again. I'd say so much again. It hasn't been that much. I need to do more cardio so I burn off more calories when I'm exercising. Anyway, create an open scene. You've done it before, it's time to do it again. We must start a new project and import the starter files. Okay, so I did that as you can see over in Unity. We got our whole starter project thing right here. We got the asset files all already ready. Our course library stuff, etc. So we got all that. So we're okay on this part. I think I can just well, let me just make sure. Click download, import. Open your project scene and delete the sample scene. Click run to see the particle effects. I did not hit run. Okay, so the particle effects is just some fog. Some fog rolling. Set up the player and add a texture. We got an island for the game to take place on, and now we need a sphere for the player to control and roll. I feel like for these parts, I don't need to read. I think for the camera stuff, we'll look at that. But this stuff is simple enough. So we'll just create a sphere, rename it player, scale to 1.5. Let's do that. Sphere. That is a sphere. And we'll make the scale. Big boy sphere. Rename it to Flare. From the textures, drag a texture onto the sphere. I like the checkerboard. Checkerboard looks fun. Add a rigid body component to it also. Make sure it's 3D one, and we got all that. So now we have a sphere. It is sitting right there. We did it. But now we need to create a focal point for the camera. We want the camera to rotate around the game in a smooth and cinematic fashion. We need to pin it to the center of the island with a focal point. So this part is new stuff. The other stuff was stuff we already knew. I guess looking at this video will probably show us if we need to go back and look at anything. If they suddenly did like 20 things they don't mention in the directions. But anyways, learn mode.
We've added our player object to the scene now, and for this game, this entire platform is going to be the center point of our entire player view. And we're actually going to make it so that they can manipulate the view itself. So we're going to use the camera to be able to do so. How we're going to do that is we're going to need a central point here, exactly where the ball is that we can actually rotate around. So we'll create an empty game object in our hierarchy. If we right click, create empty, we have the game object. Now you can see it spawned at a strange position, so we'll fix that just a little bit. If we go to transform and we click on the gear icon, we can reset the position. So now our empty game object is exactly in the center of our scene. We're going to name this the focal point. So in this case, this game object will be the center point of our entire scene. It's especially useful that this is an empty game object because this is literally just going to be a position and a point that we rotate around. In order to control the camera, we can actually left click on the main camera in our hierarchy, drag and drop it onto the focal point game object. So now the main camera is a child object of our focal point. And so, in fact, because the main camera is always tied to the location of our focal point by doing this, if we rotate our focal point, for example on the y-axis, our camera will actually rotate around the game view based on that focal point. So it creates this really cool effect, and the center of our platform is always the center of our camera. So I'm going to reset that really quick. So now it's back at the center. Now with that in mind, what we can do is use code to actually control the rotation of this focal point. So if we go to our project window, right click on assets, and we're going to create a new folder. And this folder will hold all of our scripts. Now in our scripts folder, we're going to right click on that. We're going to create a new C# script. And this script will be called rotate camera. And this is what we'll use to control the rotation. Now we're actually going to drag rotate camera onto the focal point. So now that the script is on our focal point, this is how we can change the rotation of the y-axis so that the camera always rotates around that point. So now it's your turn. You're going to right-click on the hierarchy and create an empty game object. We'll rename that game object to be focal point. You're going to left-click and drag your main camera onto the focal point, so that way it's nested underneath the focal point. You're going to go into your assets folder, right-click, create a new folder for our scripts, and then in our scripts folder, you're going to create a rotate camera script. And then that rotate camera script you'll apply to the focal point, so that way we can give the player control of the rotation of that point. Now it's your turn.
That was, that's interesting. And, didn't think you could do something like that. Just putting the empty on. As the point. I'm guessing I should probably name it what they have it named. If I made a video game, I would definitely name these all pretty stupid things, probably. Create the rotate camera one. Reset the position. Throw the camera there. Yeah, that's actually pretty cool. Oh. There's 2 moons. Okay. We need to attach the rotate camera script to the focal point. Okay. Did that. That is complete. Rotate the focal point by user input. Now that the camera is attached to a focal point, player must be able to rotate it and the camera child object around the island with a horizontal input. And watch where you're going, rotate the focal point by user input. Based on rotation, speed, and horizontal input. Okay, well that sounds pretty simple, but we'll watch it anyway. Just to make sure, right?
Now that we've applied our rotate camera script onto our focal point, we're going to add in some code to control that rotation. So if we go into the rotate camera script by double clicking, in our rotate camera script, what we're going to do is we're just going to test this really quick. So if we do a transform to get the transform property and we rotate, now we're going to rotate around the y-axis, so we're going to use the vector 3 up to get our y-axis, and we'll just rotate this at a speed, an angle called 1 for now, so it'll update at 1 degree every time the frame updates. So now when we save in Unity, when we press play, in our game you can see that we're slowly rotating around, which is really good. So now in our rotate camera script, we're going to create our own variable. In this case, we'll just make it public for now. And this will be a float. And this will be the speed of our rotation. So we'll call it rotation speed. And then in our update function, we're going to create a variable so that we can actually get the player's input. So this will be float, our horizontal input, and we're going to use our input manager, and we're going to get the axis that we're going to use, which in this case will be our left and right arrow keys. So we're going to use our horizontal axis, and then we'll close that statement off. And then in our transform rotate, we're going to use our horizontal input to control our rotation speed. And then we don't want to update that every single frame. We just want to update it over time. So we'll use time.delta time. Now when we save, now when we go into Unity, when I press play, if I press the arrow keys, nothing happens. Let's see. If I stop playing really quick, I think, let's see if I go to my focal point. So I don't actually have a rotation speed, so let's set this to 50. So now we're actually multiplying by a value other than just always multiplying by 0, which gives you 0, which means no movement. So now when we press play, if we rotate, we can rotate to the right, we can rotate to the left, and then we can tweak the values to be a little faster, a little slower, depending on how much control you want the player to have over the camera. So now it's your turn. In your rotate camera script, you're going to create a rotation speed variable. You're going to create a horizontal input variable in your update method. You're going to call the input manager and use the getAxis method to use the horizontal input, which is our left or right arrow keys. And then you're going to create a transform.rotate method. It'll rotate around the y-axis or our vector 3 up. And then you're going to multiply the horizontal input by our rotation speed and make sure that it updates over time. Now it's your turn.
I wish I wasn't so tired all the time. I didn't do my writing stream today. I didn't get a caption done, and I was emailing some people about setting up commissions, so I did work in general. I just got paid, actually. Just on the side there. It happened. Come to think of it. Hang on one sec. Just gonna check that really quick. Make sure that's all fine. Okay, someone else wants another 10K story. That's not terrible. Hmm. Let's see. Create the code or rotate the camera. Station speed. No, I just make it an image so you can't. So you can't copy and paste it. Excuse me. It's yawn day. Today. It's all yawn day. Yawn ray. Where's my script? There we go. That is what we like to see. Words. Okay, so we're creating a camera rotation. So we already know we're going to want a public float. It'll just be rotation. Speed. And then we want a float inside of the updates. All that. Input. Make sure I actually spell it right. Equals. Get access. Get access. Write that right. Okay, semicolon that. And then we do our transform. Rotate. Because we're rotating the camera. Vector 3. We're using up because it's the y-axis. That's just giving him 1 to the y. And we want our horizontal input. Yeah. Horizontal input. And then we're multiplying it by the rotation speed. And we're multiplying that by time delta so it runs at a normal speed that we can comprehend. I did not space that. What did I do? Did I write that part wrong? Float equals, that's right, vector up. I don't know what's wrong. I'm actually confused. Oh, I know what's wrong now. Because I don't want to comment either. Dummy. Yeah, we're only doing the axis and then the angle. The angle is the input. Okay, so that is all good now. We can save that. Leave a comment. Okay. I'd like to leave a little comment just so we know what all that is. Now, like in the video, we have rotation speed here. I'll set it to 50 and see how that goes. Since our frame rate is better than that guy's, or worse, rotation speed probably be different. Oh yeah, it's actually WASD or whatever. But it is working correctly. Okay, there we go. That is more correct now. We got that. Add forward force to the player. So let us go into learn mode.
Great, so we have our camera rotating perfectly around the island, and now we need to create some controls to be able to move the player around. So we're going to go into our project, in our scripts folder, right-click, and create a C# script. And we'll name this the player controller so that we can control our player's movement. Now we're going to left-click drag the player controller onto our player. And now we see the player controller is attached. So we'll open up our script. Now, in our player controller script, we're going to create a speed variable. So it'll be a public variable so we can play around with it. It'll be a float, and we'll call it speed. Just so we don't have the same problem like we did with the rotation, we'll give this a default value, so we'll make it 5 for now. Now, because we'll be controlling our player using forces, we'll actually need to get a reference to our rigid body. So we're going to make a rigid body variable. So it'll be private, and it's a rigid body. And we'll name it the player RB for player rigid body. Now, in our start method, we are going to get our player rigid body, and we'll set it to the component of our rigid body already on our player object. In our update method, we're going to get another input for forwards and backwards. So we'll create a float, and we'll call it forward input. And we're going to use our input manager, and we're going to get the axis for our up and down keys. So we'll need our vertical axis. And then to actually apply the force on our sphere, we're going to use our rigid body, and we're going to add a force, and the force that we want it to move is in the forward direction, so we'll use vector3 dot forward. We'll multiply that by our forward input, and then we'll multiply that by the speed that we want it to move. And then we're going to close our statement, and we'll save our script. Now in Unity, when we press the forwards or backwards, up or down arrow keys, you can see that the player moves forward, and then we apply force backwards, and they move backwards. And we can rotate the camera. And so we have some player movement. So what you're going to do is you're going to create a new player controller script in your scripts folder, apply that script onto our player object. In our player controller script, we're going to create a variable to get a reference to our rigid body. We're going to create another variable to hold our speed, and we'll initialize it to 5 for now. In our start method, we're going to get that reference of that component that's already on our player. In our update method, we're going to get the input for our up and down arrow keys, and then we're going to add a force to our player's rigid body in the forward direction, controlled by our forward input at the speed that we set it to. Now it's your turn.
Alright. Well, let's do all of that. Let us do all of that. We're making the player controller. First, well, the player controller script. No new script to this. Player controller. Throw it onto the player. Open up the player. Oh wait, wrong click. Open up the script. choke on your own spit. Just a little bit. Just a little bit. We're making a private and a public. Float. Speed. This is the equals one, right? Yeah. Oh. No, that's wrong. No, that's right. So we're going to the void start then to define our rigid body. So we have the player rigid body, and that is equal to the rigid body. We should get components. Rigid body. Okay, and that sets the rigid body, so we have that now. And then we make our actual thing that's happening right on over here. Another float. Word input equals. Does this get access? Yeah. Vertical. Make sure I spell it right. Okay, so we got the vertical. We now have the buttons you pull from, but now we need to actually set what is happening when you press said button that we just defined. So we want it to look at the player's rigid body, and we want to add force to it. We're adding force to it with a forward. We'll times that by speed, and then times it by forward input. So it knows when we're pressing the button, and we close that off, and we're all good. Okay, made a little comment. Leave a comment. We already have force applied, so yeah, that happens. Probably a bit too fast. Maybe a little too fast, but we got that. And now we need to move in the direction of the focal point. So this isn't where we're going to make tank controls. That was what I was curious about. So yeah, we're just taking the transformation or the focal point and using that as our forward motion. instead of a normal vector 3. We're applying the focal point's transformation, which would be the rotation. So we're going in the same direction as the rotation of the camera. That's interesting. It's weird to think about it like that.
We've added in controls for our players, so then that way we can move them up if we press the up key, or backwards if we press the down key. If we press the left or right arrow keys, you can see that we rotate around our scene. So now what we want to do is we actually want to push the player in the direction that the camera's facing. So for example, if we're facing this way, we want our player to go directly up in our game view. Now, an interesting to note is this button in the top left for global or local. You can see when I change it, the positions of those arrows actually change. So currently you can see actually what is the Y direction of our ball as it's rotating. If we take a look at our focal point, we can actually see which way is currently the front of our focal point, the direction that our camera is facing. So if we rotate our camera and we watch these axes, you can actually see the Z-axis pointing in the direction that our camera is pointing. So you can see our camera, there's the direction. In our game, as we rotate, you can actually see that the camera is following those local coordinates. Now, it's helpful to use local coordinates in a case like this when you're actually trying to set up your scene and set up your environment and you want everything to be in the same place. Using something like our global coordinate system is a lot better. So then that way you can make sure that when you're changing the positions of things, or you're changing the rotation or anything like that, you can always make sure that when you drag these arrows, it doesn't drag it off. For example, if I change this to local and I rotate the Y, when I drag the Z, it's not actually going directly forward on the Z, it's going at an angle. So we'll reset all of that. So using global and using local are helpful for different situations. So in our player controller class, what we're actually going to do is get a reference to our focal point. So that way we can know when the focal point is facing in a certain direction, we will move that player in the direction it's facing. So we'll create a new private. Since our focal point is a game object, we need a game object variable. And we'll just call this the focal point so we avoid confusion. In our start method, we want to get a reference to that focal point. So we'll get our focal point variable and we'll set it. Now in this case, because our game object is in the scene, we can use GameObject.find. So this will find that game object in the project hierarchy. And we can actually just use the name. So we called it focal point with capital P and F and spaces. So now we have a reference to that focal point. So now instead of moving the player in the forward direction of our world, we'll actually make it the forward direction that our camera's pointing in. So if we use our focal point and we get its current transform and we get the forward direction that it's facing, now if we go into Unity, when we press play on the editor, you can see that I can still move forward or backwards, but then if I rotate the camera, say 90 degrees, now when I move forward it goes in that direction, and when I go backwards it goes in the opposite direction. So now we can actually use our camera to be able to control how our ball moves in the scene. So what you're going to do is you're going to add your own private game object variable for the focal point. In your start method, you're going to get a reference to the focal point in our project hierarchy and set that to our own variable. And then in our update method, instead of using the vector3.forward, you're actually going to use the forward direction of our focal point. Now it's your turn.
That's an interesting way to handle tank controls. Huh. So it would be the same thing, just the empty in this case would be following the player, and then when you turn, that turns your body, so it turns the forward. Yeah, so it's like the same thing, it's just usually in those old games, the camera wouldn't move. Your character would have to move. They were the tank point, or the focal point. Interesting. Well, let's write this. I already got down the focal point part. So now we are going to go into our player RB, get rid of the vector3 forward and make it the forward point. Make it the focal point. We'll make it the transformation of it when it is going forward. And we save that. Based on the camera position. Okay, so now we'll try it. Turn the camera. This thing is a bit too fast. Okay, well, it's definitely rotating. The ball is just very odd speed-wise. And that's just the recap. So we don't need to look at that part. We're cool with that. So let's go on to the next one. Got more experience. It doesn't seem like Unit 4 is that complex, honestly. I'm guessing Unit 5 is going to be a bit more complex, but we'll see how that goes. I've been waiting for the user interface for so long. So long. Hasn't even been an hour yet. We got through one part. But now we need the other part. Okay, so is this for following everyone? I might just go through playing the videos while I silently do this, but we'll see.
In my experience, a floating island isn't really a floating island unless there's something on that floating island trying to knock you off of it. In this prototype, that means enemy spheres with one goal and one goal only. To see the player go over the edge, even if it means throwing themselves off too. Well, by the end of this lesson, an enemy will spawn on the floating island and then follow the player around trying to knock them off. Up to this point, when we've used vectors, we've always used a particular preset direction. Vector3.up, down, left, right, forward, back. The tricky thing about getting the enemy to follow the player, though, is that the direction will always change as the player moves around. So we can't use any of those preset directions. To be able to pull this off, we have to get a better understanding of what a vector really is. A vector is a distance and direction in 3D space. So if this is the enemy's position and this is the player's position, this vector describes the distance and direction between them, which also happens to be the direction we want the enemy to move in. But how do we calculate that vector? How do we get it and use it for the enemy direction? Well, you know how generally if you can add a plus b to equal c, you can also subtract c minus a to get b? It'd be like if 1 plus 2 equals 3, then you know that 3 minus 1 equals 2. Don't worry, I'm going somewhere with this, because the same is true of our vectors. Since the enemy position plus that vector equals the player's position, you can also subtract the player's position minus the enemy's position to get that vector. And that's exactly what we'll do. We'll take the player position, subtract the enemy position, and that will give us the vector, or distance and direction the enemy should move in. And to make all that happen, I'll see you in Unity. Great, so we have our player movement set up pretty well. And you can see when we move the player around, we can move it all around this platform. So now what we're going to do is we're going to introduce more difficulty into this little game by adding in enemies. If we right-click on the hierarchy, create a 3D object, and we'll make another sphere. So you can see here our sphere has actually gone underneath the platform, so we'll bring that up just a little bit. And to make things easier, we'll bring it up in front of the player. And then we're going to just make this as large as the player. Just so we can differentiate, we're going to just take one of our other textures and apply it onto the enemy sphere. So that looks pretty good. We'll rename this to be an enemy. And then we're just going to bring this closer to the ground. So let's make this just at 0. And then we'll bring this down to maybe 0.15. And then we'll just make this an even 6. Now we're going to add a rigid body to this enemy, so then that way both the player and the enemy can interact through physics. So if we go to add component, type rigid, we have a rigid body. Cool. So now when we press play, you should be able to see the player runs into the enemy ball, and it creates this little, bumps it off a little bit. So what we're actually going to do is we're going to augment the physics in small ways. So we're actually going to go into our assets folder, right-click on assets. We're going to create a new folder, and we're going to call this physics material. Now, in our physics materials folder is where we're actually going to keep all of the different physics materials that we might be creating for our different objects in our scene. If we right-click on physics materials, we're going to create a physics material at the bottom, and we're going to name this material Bouncy. So if we left-click and drag Bouncy onto our player, and we left-click and drag Bouncy onto our enemy, we'll see if any effect happens. So you notice several things. One, the friction is actually making a huge difference now. So on our physics material, we can actually apply even more physics properties. On our player, rigid bodies can store things like mass and drag and gravity. But on physics materials, we can actually change the friction of how much friction there is when something is standing still versus dynamic friction, which is when it's moving, how much friction is applied. Or we can change the bounciness, so how bouncy something will be when it runs into something else. So since this is 0, there's not going to be a very large bounce effect, so we'll set this to 1. And then one of the other things that we're going to do is under this bounce combine option, there are different options that you can select. So we can select the minimum amount of bounce that would happen when two things collide. We can create the maximum amount of bounce that would happen when those two things collide, taking the larger value of that one or that one. We can average it, so then it would actually cut those values in half. Or we can multiply it, so it'll increase the value. So the bounciness of this material and the bounciness of this material will actually be amplified. So we'll make it multiply for now, and then we'll press play and we'll see. We still have a bit of friction, but the bounce is definitely a lot more significant now, which is really good. Now, in order to check just to make sure that you have your bouncy physics materials on each of your objects, if you go to player, under the colliders, there's actually a spot for the material, and that's where the materials are applied. So if we do the same thing for the enemy, you check their sphere collider, and you can see under material, there's a bouncy physics material applied. So now it's your turn. You're going to create your own enemy. Make sure you apply a new texture to it, scale it up, position it in your scene, make sure you rename it as enemy in your hierarchy. Then you're going to go into your assets folder, create a new physics material folder. In that folder, you're going to create a physics material called bouncy. On bouncy, you're going to change the bounciness value to 1 and change bouncy combine to multiply. And then you're going to click and drag bouncy onto your player and your enemy so they both have that physics material applied. And then you can test and see how bouncy it is when your player runs into another object. Now it's your turn.
Overall, this one's pretty simple. No scripting yet. That's the next part. Okay, so let's make a new sphere and call it enemy. Enemy. Right up here. Okay, then we're adding rigid body to it. Okay, when it does basic things and it wants us to test that. Ah. We destroyed it. Just its XYZ styles and tests. Okay. They're same size as us now. No. Okay, then we want to make a physics material folder. This is when I'm lazy and just copy and paste the name so I don't have to write it. Not just because I don't know how to spell physics, but mostly that. In the folder, create physics material, name it Bouncy. Chapter 1. Use that to multiply. Let me test again. Yeah. It's at a pretty good speed that I can circle around now as long as I hold down turn. Okay, so we did that. Next.
So we've added these physics materials to our player and our enemy, so that way when they collide, creates this bouncy bump. Now, we need to make it so that the enemy can actually chase the player around the scene. So, we're going to use a script to do that. In our project window, we're going to go into our scripts folder. We're going to right click and create a new C# script. And for this, we'll just call it enemy. So this will hold all the behaviors that the enemy should manage. And we're going to make sure we click and drag the enemy script onto the enemy. And you can see it's been applied. So now we're going to go into our enemy script by opening it up. Now, in our enemy script, let's think about some of the things that we want to do. So we're going to need a speed to be able to make the enemy move. So we'll make this another public so we can fix it in the editor. Float speed, and we'll set this to, we'll set it to a little slower. So make it 3 for now. Another thing we need to do is, because we're going to try and move this object, we need the rigid body component. So we need a private rigid body. And we'll just call this enemy RB. And now we need to actually get the reference of that rigid body on the object. So we use our enemy RB variable. And we set that to the component of our rigid body on our enemy. Now, we need to move this enemy. To actually visualize what we're trying to do here, we're trying to move the enemy from their position to our player's position. Now, if we think about it in terms of how we apply the force, since we're trying to move our enemy towards the player, we should take our player's current position, and then we need to subtract it from our enemy's position. So in fact, we actually need a reference to our player. Since we know how to find our player, we'll make this a private variable, and this will just be the game object, and we'll just call it the player. In our start method, we need to find that actual player, so we'll use our player variable, and we set that to the game object in our scene. We find it by its name, which in this case we named it player. So now we have the reference to our player. And so now we need to apply a force in the direction of our player. So we need our rigid body again. And we add a force. And how we're going to add this force is we're going to take our player's position. So we need to use player, and we get their transform to get their current position. And we're going to subtract by our enemy's current position. So we need our transform here, and we need the position. So now we know the direction that we're trying to go by subtracting our player's position from the current enemy position. So that will give us the vector 3 coordinates that we need to go towards at all times. In this case, we're going to apply our speed, so that way we know how fast the enemy should be moving. One thing to consider is, because this is actually a math equation, so our computer will read this as a math equation, it will actually follow standard rules. So, because transform.position is being multiplied by speed, it'll actually do that first before it subtracts from the position. So that's not what we want to happen. We want to get the direction that we're trying to go to before we apply the speed. So we use parentheses, so then that way make sure that first we're going to subtract the player's position and our current position, and then we're going to multiply that vector 3 by a certain speed. Now let's make sure we save, and then in Unity, if we play our game, we should see the enemy is very aggressively rolling towards us. So that's good. Now, one of the things that you might see is it was going very fast. Now, the reason that happens is because as the player gets farther away from the enemy, the length of that actual vector, the distance between those two positions, becomes larger. And so what it actually does is it tries to multiply over a very large amount of distance, so it actually increases in force over time. We can actually use some code to prevent that from happening. So what we're going to do is we're going to actually create a standard strength, so that way, even if the enemy is really far away from the player, it doesn't actually get an increased magnitude, an increased strength of its force over time because the distance is larger. We can use a dot normalized after this vector 3, so this will actually normalize the magnitude of this vector. So it doesn't matter how close or how far the enemy is from the player, it will always be coming at the same speed. So if we save, so now in Unity, when we press play, we should see that the enemy doesn't move at a very fast speed and doesn't accelerate really quickly when it runs into the player, which is exactly what we want. So now it's your turn. You're going to go into your assets folder in your scripts and make an enemy script. Make sure you apply that enemy script to your enemy as a component. In your editor, you're going to create 3 new variables. So we're going to get a speed variable. We're going to get the rigid body. We're going to get a reference to the player. In our start method, make sure that you get the component for that rigid body and make sure that you find that player in the game hierarchy. And then in our update method, you're going to add a force to the enemy's rigid body, and you're going to get the player's position, subtract our current position so that we get a direction we're trying to go to. Make sure that you put both of those in parentheses so that way it does that operation first. You're going to dot normalized so that way we can actually normalize that vector so it doesn't accelerate at a very fast speed the farther the two objects are away. And then we're going to multiply by the speed that we set. Now it's your turn.
Okay, that one was actually a lot of steps. Oh, but we can do it. So, we're gonna go on over to our scripts and make a enemy script. Gonna throw that on our enemy. Gonna open it. Okay. Now we need to declare 3 new variables for rigid body, game object, Flick float. And go slightly slower. Rigid body. Okay. Now we need to declare all of those and just start. Not all of them, just the player and rigid body one. Okay, enemy rigid body. Components. It's just the rigid body. Why does it keep doing that? I'm hitting enter. Enter it. Player. Does this get component also? No, it's game object. Okay. Game object dot find. So we're finding game object named player. And then semicolon. And now we're going to make it follow us. Follow the player possessively. Dude, a very good comment. Follow the player possessively, so you both fall to your death. Okay. Enemy. Rigid body. We're gonna get an add force. What? Don't do that. Okay. Move on to the player transformation. We want two parentheses here because of how this is. As we know, PEMDAS is parentheses, equations, then multiplication, division, addition, and subtraction. So you need to do player transformation position. And once you subtract that from the enemy's transformation position, that said, then we want to normalize this and multiply it by speed. And there. And that is that. So then I'm guessing we're just going to make this a prefab and maybe make two other enemies or something to make an index that'll spawn them out. That's what it seems like we're probably gonna do. Anyways, let's see if this actually works. I have it moving slightly slower than me. Oh, too slow. Okay, well it is actually following me. That's cool. It's like it's AI, but it isn't AI. Like, is that what people mean when they say AI? Because this is just something following your position. Like, how many people actually use these things in like real, well-known games where it just like follows you and it says like shoot at player miss like every 60% or something, like out of a percentile you'll hit the player this many times, and then people are just like, wow, that was amazing AI, and it's like, no, it wasn't AI, it was just like 5 lines of code. Like that's what what was it called, Cyberpunk ended up doing, right? They had like baby code like that instead of the fancy AI, fancy smanchy AI. I don't know how AI is different, if it just like makes its own code based off of that sort of stuff. Like you give it some baseline and it's like, oh, I'll make the enemies react differently to the player based on some other situation. But hypothetically, you could set up all that stuff yourself too. I don't know, it's weird. Let's continue. I want to try and at least finish this section before I get off for the day, but I don't know. It's not that late.
So we're really rolling now. We've got our enemy that rolls towards our player, and it's not moving at an incredibly fast speed. So one real quick thing that we're going to do is we're just going to clean up some of our code. So in our update function, we have this really long line of code here. So we're actually just going to clean this up a little bit by using one variable. Now, because in our update function is the only place that we're really going to be calculating the position of the player against the current position of the enemy, this is where we're going to create our variable so that we don't need it anywhere else. So we're going to create a vector 3 because we're taking in two different positions, our player and our current transform. We'll call this vector 3 the look direction. So this will actually be the direction that the enemy will be moving towards. We're going to set this, and we're actually just going to take this line of code. We can cut it and paste it, and then we'll close off with the semicolon. Now, the reason why we keep our equation here still in parentheses is just so that we can use the dot normalized. So that way we can apply our normalized vector onto the final vector that comes out of this position here. So now that we have that in our add force, we can just put look direction. And when we save, if we test our game, you can see that the enemy is still moving at the same speed towards the player. So now it's your turn. In your update method, you're going to create a new vector3 variable for the direction that our enemy is going to move towards. You're going to take the equation that we had in our add force for the player's position minus the enemy's current position, and then you're going to normalize that entire vector so that way it doesn't increase in magnitude the farther the two objects are away. And then your look direction, you'll just add our enemy is now set up exactly the way that we want it to. So now what we're going to do is we're actually going to create a prefab of our enemy so that we can use it over and over again, and we'll actually manage all of these enemies through a spawn manager. So in our assets folder, if you right click, we'll create a new folder and we'll call it prefabs, where we'll keep all of our prefabs. We'll take our enemy in our hierarchy and we'll drag and drop it into our prefabs. And in this case, our enemy basically has all the different components that we need. I don't think we're going to change it anymore, so we can actually just right-click and delete it from our project hierarchy. Now, what we're going to do is create a new spawn manager in our hierarchy. So we right-click, we're going to create an empty object, and then we're going to rename our game object to be spawn manager. We don't really need to reset its position or anything like that, just because it's just going to take in numbers from our screen anyways. In our assets folder, we're going to go into our scripts and create a new C# script for our spawn manager. Make sure you drag and drop that onto the spawn manager object. And now if we open our spawn manager script, now we're going to need a reference to our enemy prefabs. So we'll create a public game object. That way we can drag and drop it from our prefabs folder into our editor. And we'll call it enemy prefab. And then in our start method, we're just going to spawn our enemy in a random location. So since we have a prefab, we need to use our instantiate method so that we can create another instance or a clone of our enemy prefab. We're going to need our enemy prefab to actually create. For now, we'll just spawn this enemy in a random coordinate. So we'll just make a new vector 3. And we'll just put it at 0, 0, 6. And last but not least, we're going to position our prefab in the right orientation. So we're going to use our enemy prefab, get its transform, and then just make sure it's oriented right. So we're going to use the rotation we set in the prefab. So now when we save, in Unity, we should magically see an enemy pop up somewhere on this platform. And there's no enemy. Well, if we look at the bottom of Unity, you can see that we have an error. In fact, you can actually click on these errors, and it will open up our console window. So whenever we see these errors or these warnings, they usually pop up in the console, and then we can actually take our console. If we click on the little tab, we can drag it into other places. So in this case, I'll put it next to my scene. So now we can actually see any error messages that pop up when we play the game. So the prefab has not been assigned. Okay. So we can clear that. I think so on our spawn manager, yes. So we didn't drop our enemy prefab into the variable. So let's just make sure we drop that in so there's a reference to that. So now that our enemy prefab has a reference to our actual prefab, when we press play, should see our enemy pops up and then they bounce, and then we'll see if we can escape. I'm too fast. And then we both fall. So what you're going to do is in your assets folder, make sure you create a prefabs folder. Take your enemy game object, drag it into that prefabs folder so we can create our own prefab. You can then delete the enemy from the scene because I don't think we'll need to change it. Then you're going to right click in the project hierarchy. You're going to create an empty object, rename that empty object to be a spawn manager. In your scripts folder, create a spawn manager script. Make sure you add it as a component onto the spawn manager. And then in your spawn manager script, you're going to make sure you create a reference to your enemy prefab. And then we're going to instantiate that enemy prefab in our start method. And we're just going to put it at a random position for now and make sure that it's rotated in the right direction. And then just make sure that you drag the enemy prefab into the enemy prefab slot on the script, so that way there's a reference to it, and then test your game out. Now it's your turn.
Not that complex. Got a little thing going on. I created the spawn manager already. So in the spawn manager, we're going to make the public game object enemy prefab. Public. Oh yeah, also making sure I named it like that. Okay. And we want to fetch the object. So to fetch it, we need to instantiate, so we know it's going to get cloned. Instantiate to eliminate. New vector 3. Make it the 0, 0, 6. Comma. Any prefab. Transform. Rotation. And there we go. Okay, it spaces that for you automatically. And because we made it a public game object, we have to define what we're using. I'm guessing we do that because we're going to make it into a into an index later to make different balls pop out. We'll just go over to our prefabs. Drop that there. Then we load. Skirt it. Can't get me. Okay, done with that one. Now randomly generate spawn position. We're gonna make a random range, I'm guessing.
So we're able to spawn our enemy using code now, and we can set it to whatever positions that we want. But we're going to make it a little bit more random than just manually putting in a position to spawn at. So we're actually going to use the random class again to generate random numbers that the enemies will spawn at. So in our start method is where we're going to create these random positions. So we'll use a float, and we need a spawn position. Now, keep in mind, in our game, we have a certain range that we want to work in for the X and the Z. So on the Z, if we just use our spawn manager, for example, so probably about up to there, so around like 9 on the Z, so -9 or so on the other side. And then on the X, so we want to make sure that it's even. So we could probably keep it -9 and 9 as well. So for our spawn position, we'll both need an X in case we want to change the range at all. And we'll make it be a random range. And the minimum value that we want is going to be -9. And we're going to use a maximum value of 9. And then same thing for our Z position. So a float spawn position of Z. Get a random range. And we'll say -9 and 9 for that for now. And then in our instantiate method, so we can change this new vector 3. We'll make it a spawn position X and a spawn position Z. Now, if we wanted to clean this up even just a little bit more, so we can make like a new vector 3. We'll make this the actual random position. And then we can actually just take out this entire line. We'll paste it. And then where that new vector3 was, we can just call this random position. So now this line is very readable. We're instantiating our enemy prefab at a random position using the rotation that it's set at, and then we calculate that random position above it. Last but not least, now we do have a few more hard-coded values, so we'll clean that up just a little bit more just to make our code as readable as possible. So we're going to make a private variable this time of float, and we'll call this the spawn range, and we'll make that 9. So then that way, we're always keeping it within that square, so that way we don't accidentally spawn an enemy outside of the octagon shape that we have. We'll go into our random range, just change this to spawn range. One thing to note, this is a bit redundant. We could easily just make it a spawn position, but if we ever wanted to change the Z, at least now we have the option, so it just makes things a little bit easier. So now when we save and we go into Unity, when we play our game, you should see a ball spawns in a random position, and then we stop. If we try again, different position, and then one more time for good measure. And there you go. Awesome. So what you're going to do is in your spawn manager class, you can create your own private float variable for the spawn range. And we've added the ability for our enemy to spawn at random positions on our screen. Now we're going to do just a bit more code cleanup and teach you something new about creating your own custom methods. In our spawn manager script, we have in our start method a way to create a position for each of our enemies. Now in the past we've made our own custom functions before, so we're going to do that again. Now we're going to make this a private method, so that way we only need to use this method inside of this class, so we don't need it anywhere else really. For now we're going to make this a void method, so it doesn't really do anything except tell us things. We're going to call it generate spawn position, and then we can just leave the parentheses because we're not actually passing it any information. It's just going to do something. So now in our generate spawn position, we're actually just going to use this code so that we can create our own spawn position. So if we Control or Command X and we paste it into our generate spawn position, so now you can see our random position is mad at us for now, but that's fine. So what this is going to do is in our generate spawn position, when we call this in our script, say in our update, it'll create a random spawn position for us. So it'll create this random X position, it'll create this random Z position, and then it will store those numbers into a random position, which is great. Except the problem is it doesn't actually do anything from there. It just does this calculation, gives us a random coordinate, and then it doesn't actually do anything with the coordinate. Now, this is a key difference between using void functions and return type functions. So a void function you use for specific tasks that you do not need to return a value. For example, in one of our previous lessons, we actually used a spawn method using the void keyword. Now, in that case, we just wanted to create a random object on the screen, and that's all that that method did. However, when we actually use methods that return a value, we do it for the purpose of giving us information after a calculation. So, generate spawn position actually gives us a position that we need to use. So, we take out the void keyword and we put in the specific type of data that we want to come out of this method. In this case, we go from a void to a vector3. Now you can see that our program is mad at us because this doesn't return a value. Fortunately, we have a value here. We have a vector3 that we've already made, but now we need this vector3 to actually come out and result from this method. So if we actually type in the keyword return, we can return our random position. So now, when we actually go into our start method, where we had the random position before, we can actually now just call generate random position. So now, in our instantiate method, it's no longer unhappy with us. That's because, in place of our random position, when we call generate spawn position, it actually outputs or returns a random vector3 that we need. So, in specific cases where we're actually trying to get some kind of data out of our methods, we can use return types to actually get that data back from that method. Now, it's a very confusing concept, the difference between vector3s and voids, but over time, as you use them more and understand how you're supposed to use them, it gets a lot easier. So now if we actually go back into our project and we press play, we didn't actually save our game. So now you can see when we go into our game and press play, it spawns a random enemy in a random position. If we press play again, it spawns it in another random position once again. So what you're going to do in your spawn manager script, now we have the enemies following the player around the scene. And what we want to do is introduce a new mechanic into this game. And so we'll actually create a power-up to give the player some temporary superpowers. So if we go down to our project window, in our assets folder, there's a course library where we have pickups. And we can choose any kind of pickup that we want to use. I think I'm going to use this gem just because it's large, so it's a bit easier to see. So you can kind of see it there. We're going to rename the gem to be Power Up. And then we're going to just change its scale and position so that way we can play around with it. So we'll put it up there. We'll 0 this, just make these round numbers. Now, our power-up is a bit small and it's a little hard to see, so we're actually going to focus on it and make it a bit larger. So let's see what happens if we do 1.5, 0.5, 1.5. Let's just make it all around 2. Cool. Now it's very easy to see within our game. Now we're going to go to our add component in our power-up inspector. We're going to add a box collider so that we can actually collide with this. It looks pretty good. I think it fits around nicely. Yeah, cool. That's fine. And then we're just going to make sure that we check the is trigger box, so then that way we can actually collide with it with our player and then have it do something when we hit the actual gem. Now, we can add a tag to our power-up, so that way it's easier to find. And we'll tag it as power-up. And then just make sure in the inspector on your power-up to just apply that tag. And then we're going to take our power-up and we're just going to drag and drop it into our prefabs folder. And we're going to make an original prefab. And then there you go. Now we have our power-up and our prefabs, and you can see it here. So what you're going to do is you're going to go into your assets folder, go into the pickups under the course library. Now we've added our power-up to our scene. Now, as a first step to getting the power-up to work, we'll make it disappear when the player hits it, and then we'll set up a Boolean value so that we can track when the player has picked it up. So if we go into our player controller script, in our player controller script, we're going to add another method for our onTriggerEnter. And then we're going to create an if statement inside. So if the other thing that we run into is a power-up, then we should do something. So since we get the collider of the thing we're running into, we can use other, and we'll compare the tag since we applied that when we created our power-ups. Then what we're going to do is we're going to destroy the power-up that we pick up. So the other game object. Now we need to know that we actually picked up this power-up, so we're going to create another variable. This one will be public so we can see when it turns on, and we'll call it bool, so that way we know if it's on or if it's off, if it's true or if it's false. Has power-up, and we'll set this to false by default. And then in our onTriggerEnter, when we run into the power-up, then we can change our has power-up variable to true, so that way we know we have it. And then, if we click on our player, we should see the has power-up Boolean on our script. When we press play, if we run into our gem, you can see that our has power-up is turned on. So what you're going to do is in your player controller script, you're going to add a Boolean variable for has power-up, and then you're going to create another onTriggerEnter method, and in that method, we're going to check if we run into an object and that object's tag is power-up, then we set our own has power-up variable to true, and we destroy the other game object. Now it's your turn. We've added in functionality so that we can actually have the player run into our power-up, and then on our player game object, you can see that has power-up turns to true. Now this power-up will be very useful only for a specific circumstance when our player runs into one of our spawned enemies on our screen while we have the power-up. Now one thing we want to make sure we do, just to make our lives a bit easier, is if we go into our prefabs folder, if we double-click on our enemy, we want to set their tags to be enemy, so we'll add a tag. Make sure you add a custom tag for enemy, and then go back to the enemy under the prefab window, go to the tag section, add the enemy tag, and then we can leave our prefab window. So now we have a tag for our enemy. Next, we're going to go into our player controller script. And in our player controller script, we're actually going to create a new method underneath onTriggerEnter. So we're going to make an onCollisionEnter method. Now the reason we actually want to use onCollisionEnter versus onTriggerEnter is because onTriggerEnter is useful when you are just trying to understand triggers between colliders. But if you're trying to do something with physics, you use onCollisionEnter instead. In our onCollisionEnter method, we're going to check again for another condition. So we need an if statement. So if the object we're colliding with is an enemy, and if our player has the power up, then we should do something. In this case, we're just going to use a debug.log statement for now, so that way we know that it worked. So if we debug.log, so that way we can see it in our console. Now we can type in a string, so we'll say collided with. And now what we're actually going to do is something called concatenation. So we can actually add strings together to be able to create one entire full message. So we have this first string that we typed out literally using our quotes. And now we actually want to know the name of what we've collided with. So we would get the collision.gameObject.name. And you see when we use .name, we actually get a string back. And then we use another plus sign, and then another set of quotes for a literal string again, with power up set to, and then if we do a plus, and then we use has power up, so this will tell us when we've collided with whatever we collide with, an enemy, it will tell us that our power up is set to true or false. In this case, it'll be true because we've added that in our if statement. So you can actually use variables and strings in an entire message for a debug.log. So that way we have a string, and then you add in another string, and then you add in the string literal once again, and then you can even add in different variables like booleans or integers or floats if you're looking for some precise information. So now when we save this, so in Unity, when we press play, if we pick up the power up and then we hopefully collide with our enemy, there you go. On the bottom, you can see collided with enemy clone with power up set to true. Or if we check our console window, you can see it up there as well. So we've set up our game so that when we pick up the power up and then we collide with our enemy, we should get a console statement saying that we've collided with our enemy. Now we're going to add a little bit of programming so that way when we actually collide with the enemy, they get sent flying away. In our player controller script, we're going to go down to our onCollisionEnter method. Now, since this is the place where we actually interact with our enemy when they collide, this will be the best place to be able to do this entire interaction. Now, in our if statement for our collision, we'll actually need our rigid body for our enemy. That way we can actually apply forces to it. So we'll call it the enemy rigid body. So we set our rigid body when we collide with our enemy. We get its game object, and then we get the component that we need. In this case, we need the rigid body. And then we actually need to calculate the direction that we're trying to go away from the player. So we need a vector 3 for that direction. We'll just call it away from player. And to calculate this, we need to take the enemy's current position and subtract it by our current position. So now we know what direction the enemy is coming in, and what direction we should send it back by subtracting by our current position. And then last but not least, we're going to apply a force to that rigid body. So we add a force. The direction we send it to is in the direction of our vector 3 that we set up away from the player. We'll multiply it by 10 just as a random value. And we want to make this an instant interaction, so we're actually going to use a force mode and use impulse so that it applies the force immediately. Now, after I've saved in Unity, when I press play for my game and I pick up this power-up, you can see when I hit the enemy, it gets sent flying off in the opposite direction. Last but not least, we're going to go into our player controller script. Now, we're going to create another variable just to hold the actual strength of that interaction. So we're going to make it private. Since 10 was a pretty good number, maybe we'll make it 15 just to add a bit more. We'll make it a float, and we'll call it power up strength. And we'll set it to 15. And then in our on collision enter, where we add the force and multiply it by 10, we'll just use power up strength. Now, what you're going to do is in the player controller script, in on collision enter, inside of your if statement, you're going to add a line of code so that we can get the rigid body of the enemy. And then you're going to add another line to get the direction that we should send the enemy away from the player. And then you're going to apply a force to that enemy in the direction away from the player times our power-up strength variable, and make sure that the force is applied instantly using force mode.impulse. Now it's your turn.
I might have messed something up in the last one. Wasn't getting the thing back. No, it looks like we get rid of this in the next one anyway, but let me just make sure on this again. Tang, collision, collide with, plus collision game object name, the power up set up to, plus has power up. Yeah, it looks correct. I have the power up set to a trigger. Oh, that time it did it. Collide with enemy clone with power up set. Okay, now we're gonna make a private float. This one is the power up strength. Is power up actually one word? That seems too strong for this thing, so I'll just make it I'll make it 8 for now. I'll just enter that a few times. Okay, so then down here, we want to add rigid body, Collision. Vector away from player. Okay, so now we're defining other things. I don't know what else to say. Still keeps doing it. Rigid body. There we go. Enemy. Collision with a game object. Let's see. Get component. For the rigid body. And then that's what that does. And then we want a vector 3. Away from player. Why is this one parentheses? Oh, because it's a calculation. Position. And then I want enemy rigid body. Add force. Away from player. Times. Power up strength. Force mode impulse. And there. Okay, so now when we get the power up, and then hit it, it gets tossed aside. We got our super power up. Okay, that's neat. Wait. Power up. Yeah, that's everything we just did. Okay, so now we need to create the countdown, add a power up indicator, and then we're done with this section. I might end it there. Not sure. We'll see. I think ending a little early is fine. Today, pretty much for me, has just been setting up stuff for tomorrow, I feel like, but that's okay. I did some things today, and that is good.
We can pick up our power up now and run into our enemy, and it will fly off into the distance. Now, the problem here is that our power up basically lasts forever, and that's not entirely fair. So, we're actually going to add a timer in so that we can remove this power up at a certain time. In our player controller's script, we're going to go down underneath our on trigger enter, and we're going to create a new method. So this method is going to be a little strange. It's called an IEnumerator that will call our power up countdown routine. Now, an I enumerator is something in programming and C# known as an interface. In this case, it's not entirely necessary to go into how it works or what it does, but it is very helpful to be able to do certain things like enable a countdown timer outside of our update loop. The way we're able to use this countdown timer outside of our update loop is through use of something called coroutines that will be able to run with a function called wait for seconds. Now, to be able to make this entire process work, we actually need to use a keyword called yield. And so this will actually enable us to run this timer in a place outside of our update loop. So if we type yield return new, and we're creating a new wait for seconds. And we'll wait for, let's call it 7 or so seconds. So now our I enumerator is going to create a new thread outside of our update loop, and it will use the wait for seconds method to wait for 7 seconds before we do something. Now, it'll wait for 7 seconds, and then eventually, once that timer is stopped, we can set our has power up to false, and then we're able to reset our player's state back to before they picked up the power up. Now, in order to actually use this method, we then need to use another method, which we'll put inside of our onTriggerEnter in our if statement, because that's when the players picked up the power up. We're going to start a coroutine, which will actually start that thread, start that loop outside of our update method, and then we call our power up countdown routine. So it'll start another thread, use the power up countdown routine, wait for 7 seconds, set our power up to false, and then we'll be back to the way we started. So then we go in our game. Let's take a look at the player and just watch the has power up variable. Watch that checkbox. Pick up the power up. Enemy goes away. And eventually has power up should turn off. There you go. So what you're going to do in your player controller script, you're going to add this line of code to create an I enumerator method. In this I enumerator method, make sure to use yield return new wait for seconds. That way it waits for a certain amount of time before it actually does this. Sets our power up to false. And then in our onTriggerEnter, when we've picked up a power up, we start a coroutine and use our Now, the functionality of our game is almost there. We can pick up this power-up, and then after a certain time, the power-up goes away. And then when we hit the enemy, they fly off into the distance. But one of the small problems is that when the power-up is set back to false, we have no way of knowing when they've picked it up and when it's been turned off. So we're going to add a visual indicator to be able to tell when we've picked it up and then when the cooldown's done. We're going to go down to our project window, down underneath the assets folder, underneath course library. If we go to power up indicators and open that, you can see there's a lot of different options that we can use to be able to see when we've picked up a power up. Now we're going to select one. So I think in this case, I like selection ring 2. So I'm just going to drag it into my hierarchy. Now I'm going to rename this to power up indicator. I'm going to fix its scale a bit just because it's a little bit too small. You can't even see it inside of the player. That looks pretty good. It's a little high, so we can actually, let's see if we can bring it down just closer to the ground, something like that. Cool. Now what we're going to do is we're actually going to, in our inspector, underneath the power up indicator, you can see this checkbox next to the name and next to the blue cube right at the top of the inspector. If we actually uncheck that, so it actually sets that game object as inactive. So when we turn it on, we can see it. When we turn it off, it disappears. So that's just kind of useful whenever we have different objects that we don't need to show right now. In this case, like the power up indicator. We only need to know when we have the actual power up, so that's when we turn it on. Now what we're going to do is in our player controller script, we're actually going to create a reference to that power up indicator. So we need to create a public so we can drag it into the editor. Game object, power up indicator. And then before we get too far, because I make this mistake too often, in Unity, if you click on the player, just make sure to drag the power up indicator directly in. So now we know that they're attached. Now, in our code, since we have that power up indicator, when we pick up the power up, we should know that it's on. So if we type power up indicator and we get its game object, so you can actually use a method to set something as active or inactive. So since it was inactive in our editor in Unity, we can just set this to true and it'll turn back on. And then in our power up countdown routine, since this is where we turn has power up to false, we can set power up indicator game object and set this active false. So this will turn it back off. So we'll just make sure that works really quick. We go pick up the power up. You can see the indicator on the ground. And then when has power up is false, and it turns off. So one last thing we need to do, it looked a little weird because it wasn't actually following the player, it was just on the ground. So we can make it even cooler by having it follow the player. So in our player controller script, if we go to our update method, we can actually set the position of the power up indicator to the player's position. Now, when we press play, you can see when we pick up the power up that our indicator turns on our player. So there is one problem, so this will set the position to be exactly the same as our sphere. So we actually just need to offset it just a little bit. So we'll just use a vector 3 for now. And we don't want to move it on the X. We do want to bring it a bit lower on the Y. But then we keep it the same on the Z. And now in our game, we press play, pick up the power up. You can see that our indicator is following us on the ground. Hit that enemy out of there. Goes away. Perfect. So what you're going to do is in our course library, make sure you go to power up indicators, drag one of the indicators into the hierarchy. Make sure that you set the power up indicator to inactive and just make sure to rename it so it's easier to find. In our player controller script, we're going to make a public game object for the power up indicator. So then we can just drag the power up indicator from our project hierarchy to that variable. Make it so that in your update method, the power up indicator actually follows the player as they move around. In onTriggerEnter, make sure to set the power up indicator to active using the setActive method. And then in the power up countdown routine, make sure to set active to false. Now it's your turn.
I kind of think it looks cooler with it around the ball, but you know. So let's look at what we got. I already unchecked it to active, I referenced it. We declared it a public game object. And the player collides with the power-up, set the indicator object to active, then set it to inactive when the power-up expires. So, power-up indicator game object set active for on trigger. Oh. Okay, and then our other one, in our power-up count scene routine, we need to make sure when it's false, we know to set it to inactive. So the power-up indicator, game object, set active, false. And then, even though we don't need it, we can update the power indicator transform position equal our transform position. Honestly, I don't think I don't know if I should bother with the other thing. It kind of looks cooler. I guess it looks clunky. Makes it not really look like it's like you're rolling a ball. New vector 3. (0.5f) 0. Let's see how that looks now. Oops. Well, why is it spinning though? Should it be spinning?
in Unity, if you click on the player, just make sure to, and then active. One last thing we need to do, look the power up that our indicator turns on our player. So there is one problem, so this will set the position to be exactly the same as our sphere. So we actually just need to offset it just a little.
Why would it be spinning like that? As far as I can tell, it's the same thing.
Now the functionality of our game is almost there. We can pick up this power up, and then after a certain time, the power up goes away. And then when we hit the enemy, they fly off into the distance. One of the small problems is that when the power up is set back to sets folder underneath course library, if we go to power up indicators and open that, you can see there's a lot of different options that we can use to be able to see when we've picked up a power up. Now we're going to select one, so I think in this case I like selection ring 2, so I'm just going to drag it into my hierarchy. Now I'm going to rename this to power up indicator. I'm going to fix its scale a bit just because it's a little bit too small. You can't even see it inside of the player. That looks pretty good.
Was it because I changed the Y? Was that what happened? I think that's why. No, that's not why.
It's a little high, so we can actually, let's see if we can bring it down just closer to the ground, something like that. Cool. Now what we're going to do is we're actually going to, in our inspector,
Does it matter if you do that? Yeah, it's still spinning with it. Why is it spinning with it?
underneath the power up indicator, you can see this checkbox next to the name and next to the blue cube right at the top of the inspector. If we actually uncheck that, so it actually sets that game object as inactive. So when we turn it on, we can see it. When we turn it off, it disappears. So that's just kind of useful whenever we have different objects that we don't need to show right now. In this case, like the power up indicator, we only need to know when we have the actual power up, so that's when we turn it on. Now what we're going to do is in our player controller script, we're actually going to create a reference to that power up indicator. So we need to create a public so we can drag it into the editor. Game object, power up indicator. And then before we get too far, because I make this mistake too often, in Unity, if you click on the player, just make sure to drag the power-up indicator directly in. So now we know that they're attached. Now, in our code, since we have that power-up indicator, when we pick up the power-up, we should know that it's on. So, if we type power,
would that change it? Why does it keep rolling like that?
And we get its game object. So you can actually use a method to set something in, since this is where we turn has. So this will turn it. You can see the indicator on the ground. And then when has power up is false, and it turns off. So one last thing we need to do, it looked a little weird because it wasn't actually following the player, it was just on the ground. So we can make it even cooler by having it follow the player. So in our player controller script, if we go to our update method, we can actually set the position of the power-up indicator to the player's position.
Oh, that was the issue. Okay, now I understand. Huh. Well, I mean, that's pretty cool. That's pretty cool. I had the player connected to the object, and you weren't supposed to do that if you wanted that to function how it's supposed to. Feel like a little dummy now, but it happens. Clear instructions. I was just a little dumb. Player that rolls around and rotates the camera, power up that grants super strength, and an enemy that chases the player until the bitter end. And this lesson will wrap things up by putting these pieces together. First, we'll enhance the enemy spawn manager, allowing it to spawn multiple enemies and increase their number every time a wave is defeated. Lastly, we'll spawn power-ups with every wave, giving the player a chance to fight back against ever-increasing horde of enemies. Okay. So this is more nitty-gritty stuff, but it's really just cleaning up some code and adding a few extra things in for stuff that we sort of know. It seems like it's shorter, but I think I will end the study session here for the day, and we'll pick up more tomorrow. I do have some commissions now to do, so not like right now, but in general, I'll have more commissions to do now for this week, so hopefully we can get through that this week and start a new one then the next week. Or I guess this week if we get it done fast enough. We'll have to see. But writing time might last a little longer if I have commission stuff. But we'll see how that works out. Either way, I want to try and at least dedicate, like 1 or 2, well, hopefully at least 2 hours to Unity learning. However that stuff works out. I think it'll be better if I, one, have dinner already prepared so I can just heat up leftovers and then actually exercise in the morning. Haven't always been sleeping the best. So if I can actually manage to exercise in the morning, then I don't have to stop stream, exercise, eat dinner, and etc. Then I can just eat dinner and get back to work, or have my dinner at the table while I'm doing Unity learning, and just eat when I'm paused between watching videos, which is a lot better. But yeah, we learned a little bit today. We learned some other vocabulary, like the return function. Is that the right vocabulary? I don't remember. Parameter. We learned new thing. I'll need to write down the stuff that is used for a timer. What was it? Emulator. Emulator. So it's just telling you that you're waiting for 7 seconds. And then after 7 seconds, it makes the power-up thing false. And it deactivates that. It's just so interesting, like, what you could do. I keep getting ideas in my head for what I could do for this walking simulator thing. And, I'm really gonna have to take notes on this stuff. Save scripts to use them as examples for my own game. Because I could use a lot of this stuff to make dumb effects, like, you know, wall oozes green slime, or some monster chases you, for example. Like this ball thing, I can make a monster chase you, and when it hits you, you get a game over or whatever. And I'm guessing for the user interface stuff, we'll get like the actual displays for, oh, this is how you make a replay screen, or a game over screen, or a menu. You know, it'll be interesting to see that stuff, so I'm looking forward to it. But I'm gonna actually announce, instead of gushing about what comes next, and we'll keep taking the baby steps through it. Just to think, this is only the second mission. Unit 4, second mission, and we got 2 more missions after this. Honestly, it makes me wonder what the next 2 missions are gonna be, because I feel like this has taught a lot. For programming, it has definitely taught a lot. And this is all just beginner programming, and I barely even grasp it. I somewhat get it now. It seems a lot easier when you get into it and start writing it yourself. It's like, oh, well, I guess that logic makes sense. But some of the stuff is a little weird, like the double ands or the double equal signs and all that junk. Anyways, actually gonna go. For anyone who dropped in, thank you for watching. For anyone who might ever watch this for educational purposes, cool. Hope you learned with me somewhat. Seeing it in practice, even though that you can't see it fully, because I can't show all the windows. Or I guess I could, but it would be annoying. But yeah, bye.